Now we're recording. Excellent. Here we go. Here are some examples that are polygons. So you notice everything is a closed shape with straight lines. And we can have some pretty interesting looking shapes as long as all the lines are straight and it's closed. These over here are not polygons. So you can't have intersecting lines. You cannot have any curves. Okay? This one, it's not closed. Okay? It's open. Here we have curves. This thing has an extending side, and this is an oval. Okay? So you can't have curved lines. You can't have something that is open. Okay, convex versus concave. Again, I'm not going to ask you for the definition for these. I'm just going to ask you to identify which type each polygon will be. Okay, convex. It says no points of the lines are in the interior. Okay, that's kind of confusing language. So what I'm going to show you is when I extend each of the sides, notice nothing goes inside the shape. So when I extend each of the sides, none of the sides cut into the interior of the polygon. However, here, okay, so if I extend that side, that one's fine. This one's fine. But then if I extend this one, notice it cuts into the actual shape. We call this concave. Here's the other side. That also cuts through the interior of the polygon, so that is concave. I like to think of concave, right? Think of concave, it caves inward somewhere. That's the easiest way. Okay, our names of polygons. These you need to know. These you need to know for the test. Okay, so I'm going to put a little star here. I'm going to say memorize. Now, hopefully, I'm going to go with half of these you might know already, maybe more. Well, let's see. Now, we also want to speak very generally. So, 3 sides is easy, I hope. Triangle. Cool. Okay, we got a triangle down. We're done. Now, 4 sides, some people might jump to rectangle or a square, but those are special types of quadrilateral. Okay, we want to say quadrilateral, not rectangle, not square, not rhombus, not parallelogram, quadrilateral. Okay, 5 pentagon, does that sound familiar? Yeah. Okay, hopefully, remember those little shape puzzles you did when you were a toddler? They had the pentagon. Okay, 5 sides, pentagon. 6 sides, we just mentioned. Hexagon. Okay, now we start getting into some terms that we may or may not know. 7, heptagon. Okay, that might be one you want to make a flashcard for. 8, like a stop sign. Octagon, good. Okay, 9, usually most students don't know off the top of their head. Nonagon.
Sounds like 9.
Yeah, it does. Yeah. 7 is heptagon, which is kind of weird because it doesn't really go with anything. Octagon, octopus, right? Yeah, nonagon, 9. Okay, decagon, the first part of the word deca means 10. Dodecagon, also think of do, that's a prefix meaning 2. So this is 2 more than 10. So 12 is dodecagon. Now you'll notice I skipped 11. It's not that there isn't a name for 11. I just will never quiz you on it. You don't need to worry about memorizing. What is it? I forget off the top of my head. It's a weird one. It's I'll look it up. Oh, And then anything beyond 12, it's not that it doesn't have a name. We don't have to know what the name is. So for example, 11, if you do get 11, you'll just put 11-GON. Or 16. There is a 16-sided polygon. You don't need to memorize those. So if it has something like 16 sides, we will just say 16-sided polygon. Okay, just as an example, or a 20-sided polygon. There are lots of names for polygons. You don't need to know all of them. You just need to know the ones in this table. Okay? All right, next one. You do need to know this definition. Equilateral. So think about the actual word. We look at the first part of the word, equal, or equi, means equal. Lateral. Lateral is a side, okay? So if it says equal sides, we would say all sides are congruent. You can also say all sides have the same measure. That would also be fine. Or all sides have equal length. These are all one and the same. So if you said that as your definition, all sides have the same measure, or all sides are equal length, that's totally fine. Okay, an example. Well, let me do, what do you want to do? Square, we can do a square. There is a triangle. So I'll draw a square. Okay, so if I'm going to draw an equilateral polygon, the way I would label it is all the sides are marked congruent. A square is not the only one. That's just one type. You can have an equilateral triangle. You can have an equilateral pentagon, equilateral hexagon. Okay. Next one, we also need to know. So instead of equilateral, we say it is equiangular. Well, look at the second part of the word, right? Angular. So all angles are congruent. I know I could pick square, but let me pick something else. What would you say?
Decagon.
You can make it. Oh, you want me to draw a decagon?
Okay. How about a pentagon?
Oh, let's go with a pentagon. All right. So when we make a pentagon, we think of a house. But what I do is I'll make the top two sides. Instead of going straight down like a house, I'll kind of angle it inward a little bit. Oh, like that. Okay, so that's the best way to make. What? Oh, do you want me to do it again? Okay, do it again. It's okay. We could totally do this again. Okay, I'm gonna make two sides like the top of a house. Okay. Now I want to make the two sides, instead of making it look like a house where you draw it straight downward, I want to kind of angle it inward a little bit and inward a little bit, and then connect at the bottom.
Does drawing the shapes matter?
No.
As long as you label them right.
Okay. As long as we label it. So since we want equiangular, I am going to put little arcs in each of these corners or their vertices. Okay, so if you have a pentagon, you're going to have 5 congruent angles. This is an equiangular polygon. All right, one more pertaining to equilateral and equiangular. If you put those two together, you have a regular polygon. So if I say regular polygon, that has 3 characteristics. First, it's got to be convex. If it's concave, if it caves inward, it's not going to be regular. So it's got to be a convex polygon that is both equilateral and equiangular. So how about let's make a regular triangle for this one, okay? So I'm going to make a regular triangle. And if it's equilateral, I'm going to label all 3 sides congruent. And equiangular, so I'm going to label all 3 angles congruent. 2, 3. Good. Okay, so we see in the first one, equilateral just pertains to the sides. The second one is the angles. The third one is two of them combined. All right, let's take a look. Example 1. Okay, we have some polygons here. We want to do 3 things. We want to name it by the number of sides. We want to classify it as convex or concave, and then regular or irregular. So we got 3 things we want to list. Okay. Name, convex or concave, regular or irregular. So I see some of you counting there. How many sides do we have? 10. So we're going to name it as a decagon. Good. Oops.
Wait, what do you mean irregular?
What's that?
What is irregular?
Okay, so regular means it has to be convex, and
Oh, it has to be convex.
it's got to be convex and equilateral and equiangular. Okay? If that qualifies, it's regular. Anything that is not all 3 of these is automatically irregular. Like we look at this and we're like, oh, that's a really pretty star. It looks like a regular star. But it's not, is it? What's the problem?
It's concave.
It's concave. So right away, right, we see how it caves inward here? So this is concave. And therefore, if it's concave, it is irregular. It's
because you see how the lines
it goes point inward. Another thing you can tell, it looks equiangular when you first look at it, right? These angles are congruent, but are those the only angles in that star? Oh, where's the other angles? Wait.
Oh, they're going out.
They're going out. They're like here. Is that angle congruent to this little angle up here? No. So it's technically not regular for that reason as well. It's not equiangular.
Wait, so if it extended outwards?
Yeah, so remember how, like, we talked about it to see if it's concave? If I extend one of the sides, you see how it cuts through the shape? That's how I know for sure it's concave. All right, next one. Oh, this one's a nice picture. How many sides do we have? 6. So it's called a hexagon. And is this convex or concave? Convex. Good. There's no places where it caves inward. And finally, is it regular or irregular? Regular. We can see all 6 sides are congruent, all 6 angles. Perfect. It is regular. All right. Almost done with chapter 1. Last page. Ooh. I wonder if we'll have time might have time to maybe start the homework. We'll see. Okay. These 4 figures, we need to know perimeter and area formulas. Okay? And for circle, it's going to be circumference and area. Okay, perimeter. What's perimeter stand for? It's the distance all around. Okay, so here we just add for a triangle. Area, 1/2 base times height. Familiar? Okay, hopefully we know these formulas. And you could also do base times height divided by 2. Either one. We agree with that? Divided by 2, same thing as a half. A square, adding up all the sides. Well, if all the sides are the same, we could just do 4 times the length of the side. Area, side times side, or side squared. Which, technically, could you use the formulas for a rectangle or a square? Yeah, right? Here we have length and width, or base and height, however you want to think about that. Adding up all the sides, or 2 times the length plus 2 times the width. Area is length times width, or base times height, depending. I like to use base times height personally, rather than length times width. Okay, circle. circumference is how you express the distance around. 2 pi r or pi times diameter. Does that sound familiar? Okay, if you forget them, make flashcards for this as well. Pi r squared for area. Okay, make a note. If, again, these are formulas that you need to revisit, make a flashcard. Okay, find the perimeter or circumference of, and area of each figure. We want to write exact answers and approximate to the nearest 10th place, and we're going to include units. Now, forgot to mention we might need a calculator for today. If you don't have it, that's okay. If you have it with you and you want to get it out, the graphing calculator, okay? I know we haven't talked about the graphing calculator. Maybe on, you know what, maybe on Monday when we have our first review day, I'll teach you some of the basics.
Do we need it for the test?
I don't think you need it for the test. So if you don't have it yet, that's okay.
Will it help you?
Yes.
It might die.
Oh, no. Okay.
The guy at the charger.
Let's do that. We'll do it at the end. Yeah. Let's just wait, and then you can just kind of look and follow along with what I'm doing up here. Okay. So let's do perimeter. The first one, what do we call that? That's a right triangle because it has a right square. Okay. Now, I am going to add up all the sides to find the perimeter, but we have a problem here. We're missing one of the sides. Oh no, we have to do Pythagorean. All right, so we're gonna figure out what I'm gonna make this A and this B. Remember, we already reviewed this, so A squared plus B squared equals C squared. It really doesn't matter which one is A and B, but C has to be on the other side. Here we get 36 plus 64, which adds up to 100. So C equals 10. All right, so I want the perimeter and I want the area. Okay, perimeter is going to just add up all the sides. 6 plus 8 is 14, plus 10 is 24. Okay. That's just going to be regular feet.
What is BH stand for in triangle area?
Base height. Base times height. Okay, so area is going to be base times height divided by 2. So it's going to be 8 times 6 divided by 2. Yep, it's going to be 24. There. Now I put in a little square feet. It's just a coincidence that the perimeter and the area turned out to be the same number. That happens sometimes. That's okay. They're different units. Now, that one it says exact because there was no rounding. We're going to see on the next one here, 6.2 centimeters is the radius or diameter? Diameter. So if the diameter is 6.2, the radius would be half of that, right? Remember the relationship? Okay, so...
It's right here.
Okay, so first let's do circumference. Well, if it says exact, when it comes to circles, I'm going to have pi in my answer, okay? Exact means I'm not actually going to use my calculator to plug pi in. So for circumference, it's going to be 6.2 pi centimeters. Yeah.
When it says to have exact,
Yeah. So when it's a circle and it says exact, we're going to leave pi in our answer. Now, for circumference where it says approximate, I'm going to type in 6.2 times, okay, if you have the graphing calculator, towards the bottom left, I'm going to click this button. It has a pi with a little like arrow in it. Do you see it? It's highlighted in red. See if you can find that button. Oh, it doesn't look you see it? Okay. So it has all these letters here, and I, and infinity, and E, which you'll use in later on math classes. But for this class, we're really just going to need pi. So I'm just going to press enter. And I'm going to press it one more time. And it's going to multiply that out for me. Okay, I want to round to the nearest 10th place. So if it's 19.47, it's going to be 19.5. So, okay, now I want to find area. Oops. Okay, for area, well, remember area is pi r squared. So pi times 3.1 squared. So for exact form, I'm just going to do the 3.1 and I'm going to square it. Now I just wanted to do that. You could do that on the side by hand, but I want to square 3.1, so I want to have that exact decimal, but I'm still going to leave pi as part of my answer. So it's going to be 9.61 pi square centimeters, because area is pi r squared. Pi r squared. And then for the approximate, now I can take that previous answer. So if you have that previous answer and I just press times, it's going to take that 9.61, which you could also type it in again, but if you just press the times after it, it'll take the previous answer times pi. How's that look? 30.19, so that becomes 30.2. Okay, any questions? No? Okay. We have Monday bonus and Tuesday bonus. Okay, if there's something that should be, if I say it's review and it looks new to you, or if you need to review, I'm seeing it bonus. Okay, last one. Find the perimeter or surface, or circumference for each figure described. We want to write answers in exact form, okay? And we're going to write it with units. Okay, the length of a rectangle is twice the width. The area is 20 square meters. Well, if we're not sure where to start, we can draw a picture. How about we draw a picture of a rectangle? The length of the rectangle is twice the width. Any idea of what would you do? If I'm going to introduce a variable, I could do 2x and x. Which one would be? So the width would be this. Yeah, that's what I would do. I would make this 2x and this one x. Does that make sense? We're good with that? It doesn't really matter which side we do. Now, we know the area of a rectangle is base times height, right? So base times height. So I know right here, the area is 50 square meters. So I'm going to substitute 50 here, and I'm going to substitute 2x times x. Does that make sense? Okay. All right. Well, what happens on the right side? That's going to be 2x squared. X times x is 2x squared. We don't want to take the square root yet. What do we need to do? Divide by 2. We got to get rid of that 2 first. So I get 25 equals x squared. And no, x equals x equals 5. Good.
Is it fine to go out that whole problem? I can tell it right away what it was because it kind of gives it to you. I think 50 is really kind of good.
Okay, at a bare minimum, write out that. I would do some solving because don't just, I know intuitively, but what if I gave you really hard numbers to work with? Now, my answer's not done. What was I asking for in the original problem? The perimeter. So my perimeter, well, if x is 5, yeah, because I'm going to have here this side would be 10. This side would be 5. So 2 times 5 plus 2 times 10, 30 meters. Good. Last one. Area of a circle is 64 pi square inches. Okay. Now, so we know the area So in this case, I have to figure out what the circumference is, because circles don't have perimeter, circles have circumference. But in order to figure out the circumference, I need to figure out what measure. We have to figure out the radius. So ideas, how can we find the radius, Maya?
Square root of 64.
Okay, let me do one other thing before we do that, and that is to get rid of the pi, and then we'll do the square root. Just because I won't always give you an answer that has pi in it. What if I just said it was 123, right? I would have to divide by pi and then take the square root. But luckily in this case, if we get rid of the pi, right, we just get r squared equals 64. And yeah.
Cancel it out.
Well, okay, I have pi r squared is equal to this. I have to isolate r. So in order, before I take the square root, I technically have to get rid of pi. All right? Because I will tell you there are some situations where I don't put pi as my area. Okay? But in this case, it works out nicely. We get r equals 8. Technically, it would be plus or minus, but remember, measures are always going to be positive. And then circumference is 2 pi r. So 2 pi times 8. And I want this in exact form. Exact form means I'm not using my calculator to multiply out the pi. So that will be 16 pi inches. Plain inches for circumference and perimeter. Area is the only thing that gets the little square units. All right.